All right, guys and girls, welcome back to day 2 of our statistics unit. Today, we are moving on to types of correlation and predicting them. So make sure you have a piece of paper to follow along on notes or ClassKick if that's been provided for you. We are going to be identifying the different types of correlation, predicting the correlation of a situation, identifying and predicting the correlation coefficient. So we'll get into that in a second. First, I want you to start with the warm-up. This is a little bit of a review from yesterday. You are going to make a scatter plot of the data and draw a line of best fit, then use the data to predict the exam grade of a student who studied 4 hours a week. So we're going to put hours studied on the x-axis, the exam grade on the y-axis, and then we are going to fill in and scale our graph. So go ahead, pause the video, do that. You can plot your points if you are ready. I'm going to go ahead and label my graph really quick. All right, so I went ahead and labeled my graph. Now I'm going to start plotting my data. So our first point is going to be 5 hours, and our exam grade is 80%. So I'm going to go over to 5 hours. I'm going to go all the way up to 80, and I'm going to plot my first point. Go ahead and continue to do that with the rest of your data points. Go ahead, pause the video, finish up plotting your data. All right, now that my data is plotted, I'm going to draw my line of best fit. So make sure that you have a straight edge to use and start around where your data is starting and try to get as many points on or as close to that line as you can. Should look something like this. So there's my line of best fit. I'm now going to predict the grade of a student who studied 4 hours a week. So I'm going to go to the bottom of my graph. I'm going to go to about 4 hours. And I'm going to go up to my line of best fit and say that that student would get around, what does that look like, 4 hours? Around an 80%, right? So there is my prediction. I predict that student would get around an 80% if they studied for 4 hours, okay? So moving on to our lesson for today, we are talking about different types of correlation. So as you can see, we have the definitions right there, and then we have 3 graphs. So a positive correlation is if the value of one variable increases, the value of the other variable also increases. So as you move along your x-axis, your y-axis would also be increasing. So if we look at the graphs down there, which one has a positive correlation? You should have selected the one all the way to the right. So as my x-axis, as we move along the x-axis, our numbers are going to get bigger. And so those are increasing. And as I'm doing that, my points keep going up, meaning that my y-axis is also getting bigger. That variable is also increasing. So say this is time, this is test scores, right? Like we just did in our last problem. As you study more, you're going to probably do better on your tests, okay? The next one we have is a negative correlation, which is where the value of one variable decreases as the value of the other variable increases. So one's getting bigger, one's getting smaller. So go ahead, take a look at our 3 graphs. Which one follows that trend? Which one gets larger and the other one gets smaller? That's right, it's our middle graph. So as I move along my x-axis, as the x-axis gets larger, my y is decreasing. So it's kind of going downwards. So as one is getting larger, one's getting smaller. So this is a negative correlation. Finally, a no correlation is there's no relationship between the variables. So as you look at this first graph right here, all of our data is spread out. They're not really following a trend. Some are going up, some are going down. There's no strong pattern to this graph. So that would be no correlation. All right, so that is it for positive, negative, or no correlation. When we move on, we are going to now talk about if the correlation is strong or weak, okay? So we have some definitions. A strong negative correlation is points that lie close to a line with a negative slope. The R value is close to -1. So R value right there is really what we use to talk about our correlation coefficient. So in R value, let's go ahead and write a definition off to the side. That is correlation coefficient. That's just the variable we use to define our correlation. Coefficient. And I will show you a visual to kind of help you remember what your correlation coefficient is. But basically, if it's a strong correlation, it's going to be closer to 1. So as you can see in the strong and then the strong negative and the strong positive, the R value is close to either -1 or +1. And the negative correlation basically just means that we're moving down, like we talked in the last one. And so if it's negative, our R value is going to also be negative. It's like a negative slope, right? So if I'm looking at these 4 graphs, which one looks like the points are close to a line with a negative slope? Yeah, I would say that the third one in right here, this is a strong negative correlation. Our points are very close to a line. So that means that that's a strong correlation and they are moving downwards. The next definition that we have is for a strong positive correlation. So similar to our last one, points are very close together, but this time they are moving upwards. So if you look at all of your graphs, which one has data points that are really close and moving upwards? So I would say it would be our first graph. Those points are really close to that line and they are moving in an upward trend. The next one we have is a weak negative correlation and a weak positive correlation. So if it's weak, the points loosely follow a line with a negative slope. And if it's a weak positive, they loosely follow a line with a positive slope. Their R values are between 0 and -1. So they are not closer to 1 because the correlation is weak. So it'd be a smaller decimal, maybe 0.5, 0.4. So there's not a very strong correlation, but you do see that they follow some kind of trend. So go ahead and label your weak negative and your weak positive, and then you can check your work with me. All right, so this would be our weak negative, right? Our points are more spread apart and they're moving down. And then this would be our weak positive. Our points are more spread apart, but they're moving up. If you're taking notes on a piece of paper, I would suggest maybe drawing similar graphs. They're not that hard to draw, just, a little L and then place your dots around there, your data set around there. Moving on, the table below shows, that should say the, not she, I'm sorry, the number of species of mammals on the International Union for the Conservation of Nature's Red List of Endangered Species during the years 2004 to 2012. We want you to make a scatter plot using the data in the table as the coordinate of points on the graph. Use the calendar year as the X value and the number of species as the Y value. 1 point is plotted for you. So we already have years on the bottom, species on the Y axis. And you are going to look at a pattern of points and decide if there is a positive correlation, negative correlation, or no correlation. So the first point they plotted for us is 2004. They went up to about 352. Okay, so I want you to pause the video, take a second, fill in your data points. All right, so I went ahead and plotted all of my points. So now we're going to decide if there's a positive correlation, a negative correlation, or no correlation. Take a second, think about it. We're going to say that this has no correlation. Yes, we do have some points up here that are very close together, and we have some points down here that are close together, but as a whole, there is no trend in this data. You can't really draw a line of best fit that would equally keep those points around each other, right? So we're going to say that this is no correlation. Our data is way too spread out. Okay, so as we move on to our next problem, we just need to describe the correlation that's illustrated by this scatter plot. So take a second, and like we learned about our strong correlations, our negative or our weak correlations, positive and negative. You're going to use both terms to describe this graph. So take a second, think about it. I would say that since these are pretty close together, that's a strong correlation, and they're moving downwards. So that would be a strong negative correlation. The next question asks us, what would you expect to be true of a person from this survey who watches very few hours of TV? So we're going to look at our graph. We're going to look at somebody down here watching few hours of TV. What do we expect their test score to be? well, their test score is probably going to be better, right? They're probably going to get a pretty good score. But is it possible for that person to have low test scores? Yeah, you could study and still not do very well, or you could still not watch TV and not do very well. Maybe you're doing other things. It's possible, but it's less likely. So we would say that this person would probably do very well, but it is possible that they might not. So I just wrote in there that I would expect them to have a higher test score, but it is possible for them to have a low score if they were doing something else besides watching TV, like playing video games. So it's more likely that they'll be out here, but we always sometimes have outliers in our data. All right. So here is that visual I was telling you about before. So this is just kind of talking about the correlation coefficient. So I explained that if it's a strong correlation, it's going to be closer to 1. If you could see in here, it says strong, it's closer to -1 or +1, and that just depends on if the slope is negative or positive. So if it's going down, your correlation coefficient is going to be a negative number, but if it's going up, your correlation coefficient is going to be a positive number. And then when it's weak, it's going to be between 0 and 1, so some kind of decimal. And you can see that right here. It shows you this little scale. So I would maybe take a screenshot of this, copy it down to a piece of paper if you would like, but this is a good visual to keep around. The last thing that we are going to do for our shared lesson is to predict the correlation of the situations. We're going to identify them as positive, negative, or none. And then we will also talk about their correlation coefficient, if it's going to be closer to 1 or closer or in between 0 and 1. So A, we have the amount of good weather days in the summer and the amount of days kids spend outside. So what do you think? If there are more good weather days, are kids going to be outside more? Probably, right? So that's going to be a positive correlation. So I'm going to really quickly go back to our definition from the start, right? So if one variable is increasing, the other variable is also increasing. So when we go down to back to where we were, as more good weather days, we have more days outside. Good weather increases, days spent outside also increases. So that's a positive correlation. All right, so I went ahead and wrote in there that it would be a positive correlation, right? And then our R value would be our correlation coefficient, so that little scale we just talked about. So it's moving up, so we know it's going to be a positive R value. And then we also, do we think that this would be a strong correlation? Probably, right? Like if there's good weather, we're probably going to be outside. So we would say that our R value is close to 1. It's probably a pretty strong correlation. The next problem we have says that the amount of baseball cards I buy and the money in my bank account. So if I'm buying baseball cards, if I'm buying more baseball cards, my baseball cards are increasing. The money in my bank account is probably decreasing, right? So I'm spending that money. So like those definitions we talked about in the start of the video, if one is increasing and one is decreasing, that's going to be a negative correlation. It's probably also going to be a strong correlation, since if I'm spending money, my bank account's going to decrease, right? So I would say it's close to -1, because as we're moving down, that makes our correlation coefficient negative. The last one we have is our average salary in America and car sales in Sweden. These two things have absolutely nothing to do with each other. So this would be no correlation. You could say that this R value is probably 0 or closer to 0, because people in America aren't buying their cars in Sweden. I mean, they might, but it's very, very highly unlikely. To wrap up our lesson, we identified the different types of correlation. Positive, as one increases, the other variable also increases. Negative, as one variable decreases, the other one increases. Strong correlations, the data points lie close to a line. They're pretty close together. Weak correlations show the data points spread further apart on the graph, loosely following a line. And then also we have no correlation, where they're just super spread out. When we're predicting correlation coefficient, positive strong is closer to 1, negative strong is closer to -1. Positive weak will be a positive decimal closer to 0, between 0 and 1. A negative weak correlation will be a negative decimal that's in between 0 and -1 again. So that little scale I showed you before. And then then we also just talked about if the correlation of a situation, what it is, if it's positive, negative, or none. You have a homework assignment for today that's following exactly what we did in our lesson. So please reach out to your teacher if you have any questions. Hope you guys all have a great day.